Hi guys, so today's video is on expanded form and scientific notation. So we're going to start with expanded form and what that is. So expanded form is something that you kind of learned ongoing when you take a whole number and break it down into its different parts, so the hundreds, the thousands, etc. So let's look at a quick example so we can see what we're looking at. So if I have 6,372, so if I was to bring this down into an expanded form, I would say which digit is this? This is the thousands digit, so then I just have 3 zeros. So this would equal 6,000 plus, and then we say, what is the next digit? It's in the hundreds digit. So I got 300 plus, I've got my 7, which is in the tenths digit. So this is 70, and then I have my plus 2. So this is expanded form. So now from expanded form, we're going to go a little bit further, and we're going to say expanded form using the power of 10. So in class, we've learned about the power of 10. So when we think about the power of 10, I'm just going to do it on the slide here so you can see what I'm talking about. So if we have 10 is to the power of 1. So we know 1, so 10 multiplied, so again, 10 on its own would be 1. So if we say 100 would be 10 to the power of 2, or we can say 10 times 10 would give me 100. And we can keep going, so 1,000 would be 10 to the power of 3, and again it would be 10 times 10 times 10, or you can simply say we count the number of zeros here, we know that it's to the power of 3, and we can continue onwards. So this is what we're looking at, is the power of 10. So if we're to take this and now go from expanded form to expanded form using the power of 10, we would have, so we know it's in the thousand space, so we know we have the 6, but 6 multiplied by 10 to the power of what number? In order to figure that out, again, I can just count the zeros, 1, 2, 3. I also know it's in the thousands, so I'm going to do a 3 up there. Then I have my 3 multiplied by 10 to the power of, again, so that's 2 zeros, plus 7 times 10 to the power of 1 plus 2. So we just did expanded form using the power of 10. Okay? So that's expanded form using the power of 10. Okay? So it's expanded form using the power of 10. Now, I'm going to give you another question, and this one I'm going to ask you to do on your own. So, I'm going to see if I can erase this board. I'm not sure. Oh, there we go. Fantastic. Erased very nicely. So, the next one I'm going to give you as a question to try on your own. So, you're going to try it, you're going to pause the video, and you're going to come back to me. So, here's your question. I want you to give me the answer to this in expanded form using the power of 10. So go ahead and pause your video and come back to me. Okay, welcome back. So now I'm going to go through this question really quickly. So if I was to take this number and give it to you in expanded form using the power of 10, I'm actually not going to continue this way because I'm going to run out of space. So I'm going to bring it down here. So if I do my first digit, what digit is that in? So I know this is my hundreds, this is my thousands, this is my 10,000s, this is my 100,000s digit. So I have my 100,000s digit, so it's a 3, and then how many zeros? We just simply count. So if I go through here, I know it's 1, 2, 3, 4, 5. So I'm adding my 5 zeros, 1, 2, 3, 4, 5, and then I'm adding, and I'm going to my next digit, which is my 4. I'm putting my 4 in, and I'm counting 1, 2, 3, 4. And then I'm continuing on, and then I have my 2, and I have 1, 2, 3 digits, and then I get to my zeros. And because there's zeros, there's no value there, so we don't actually have to go ahead and just write plus 0, 0, 0, 0. That's going to come out when we actually do it in the scientific notation. We're going to be able to see where we left off. So, sorry, not the scientific notation, the power of 10. So now I go ahead, I go from expanded form to power of 10. So now in this case, I go 3 multiplied by 10 to the power of what number? And I can simply go 1, 2, 3, 4, 5. And I'm going ahead and adding, and I have 4 times 10 to the power of, and again, simply counting 1, 2, 3, 4. Oops. oops, sorry, I wrote that in the wrong color there. Plus 2 times 10 to the power of 1, 2, 3. Okay, so right, there we go. And so if you've gotten that answer, you've got it correct and you've figured out how to do it. So now I'm going to give you one more question. And this time, I'm not going to give you the answer. You're going to have to bring it back to class and we'll see if you get it right. So let's go to another one. And I'm going to say, if you've looked at recent numbers of COVID cases in Ontario, you'll notice that Ontario's current COVID case count is up to 55,362. So I want you to take this number and I want you to give it to me in expanded power of 10. So expanded form using the power of 10. So that's what you're going to do for me and bring that back for me. So I'm not going to give you the answer to that question. Now, if I was to say, so I'm going to work backwards here now. I'm going to give you a number, sorry, just off screen there. I'm going to give you a number that is already in expanded power of 10 form. And I'm going to say, well, can you work backwards and bring it back to standard form? So this is referred to as standard form. So I'm going to give you a number in expanded form, and you're going to come and bring it back to me into standard form. So I'm just going to erase that. That's the question you're going to bring back for me. So let's say I have, okay, so I'm going to say it's 4 times 10 to the power of 4. And I'm saying now take this number and give it to me in standard form. So this is in expanded form using the power of 10. So I say, okay, that means I have a 4 as my first digit, and then I have 10 to the power of 4. So 10 to the power of 4 is the same as saying 10 times 10 times 10 times 10. And if I was to do this, I would get the value of, 10,000. So now I'm saying it's going to be 4 times 10,000. And when I do 4 times 10,000, I end up with 40,000. So that's working backwards. So I'm going from my expanded form using the power of 10 and bringing it to my standard form. Okay? Now I'm going to give you one more. We're going to do a little bit one that has more than just one digit. So this one is a pretty easy one, right? It gave you like just one digit, try to get you going with it or get used to the idea of it. So now let's say I give you the 8 times 10 to the power of 5 plus, let's see, 6 times 10 to the power of 3 plus 2. Okay, so that's a little bit more now here. And I'm saying, okay, I want to go from expanded form using the power of 10, and I want to bring it down to standard form. So what does this number look like as a standard number? So I know. So the trick that I taught you is the number here tells you how many zeros there are. So instead of going out and saying 10 times 10 times 10 times 10 times 10, so I do that 5 times. 1, 2, 3, 4, 5. I know that when I multiply this, I get 100,000. So instead of going through this whole process, I can say that I know this tells me there are exactly 5 zeros. So 1, 2, 3, 4, 5. The only number changing is my hundredths digit, which is going to be, in this case, 8. That my 100,000ths digit, is going to be an 8 in this case. So I already know that. So I shouldn't have to break all of that down. So instead, I just write 8, and then 1, 2, 3, 4, 5. And then I'm continuing here. Then I have 6. And in this case, I have 10 to the power of 3. That tells me there's 3 zeros. And my number that starts it is going to be a 6. So it's 6, 1, 2, 3. And when I look at the number now, I see it's 6,000. And then it's plus 2. Okay, so we're almost there. We've got our expanded form with the power of 10. And now we've broken it down just to the expanded form. So we've gone from here to here. So remember earlier in the video, we went from the bottom up, now we're going from the opposite direction. And so now, all we do is now it's just aligning the place values and nothing else. So you say, okay, if I know this is, if I know this is 800,000, my 6 goes into the thousandths place. So now it's going to look like this, and the 2 goes into my ones place. So my standard form of this number is 806,002. So there you go, working backwards in that process. So now I'm going to give you one, which you're going to try on your own. So you're going to pause the video, you're going to try this question and see how you do. So let's say I have so you're going to go ahead, you're going to pause the video, you're going to try the question, and you can come back to me. Okay, welcome back. So now we're going to go through it. And so like I taught you and already showed you, you are looking at this value being your first number. So we have a 5, and then we know that I'm adding how many zeros to that? I'm adding 5 zeros to that. So 1, 2, 3, 4, 5. And the moment I do that, I know that I have 500,000. Then I go to my next digit, I have a 3, and then I know that I'm adding 2 zeros to that, so that's where I get that from. So I'm adding 2 zeros, and I know my number is 300, and then I know that I have a 9, okay, as my ones digit. Now I'm just gonna do, again, place value, where do they go? So I have 500,000, and then I have 300, and I have 9. So again, I went from expanded form with expanded form with a power of 10, then I went into expanded form, and then I went to standard form. So again, this is called my standard form. This is my expanded form. And this is my expanded, expanded with power of 10, okay? So now you have a breakdown of how that works. So now we've gotten all that, and we're gonna move on to what is scientific notation. So we understand what expanded form is, we'll rub that off there. And now we're gonna move to scientific notation. So scientific notation is a way of looking at really big numbers in a smaller form. So if you think of a number that is really, really, really large, and we don't want to have to read such a large number, we bring it down so that we're able to read it in a smaller form, okay? So it's easier to understand what the value is without having to write out this humongous number. So, the number that we just looked at, so the one that I just erased out, so I'm gonna write that back down here. So if I have, I'll come up with another one. Okay, so I have 537,000, okay, as my number, and I want to break this number down into scientific notation. What am I going to do? So scientific notation is, I don't want to be able to say this whole number, so I'm going to come up with a way that makes it a little bit easier. I'm going to show you 2 different ways of doing this. So the first way is, if I was to take my digits that have values, so in this case my digit that have values is my 5, my 100,000s, my 10,000s, and my 1,000s. So those numbers have a digit, so I'm going to say, okay, I'm going to say 537 times, and again, how many zeros are there? We know that it's multiplied by 1,000, so that's coming down the process of how to break it down. And then saying, okay, well, I know that I can go further than that, and I can go into breaking it down. So how else would I break that down? I know that I want to not have, it's still too big a number, so I want to kind of bring this number down a little bit further, so I only have a whole digit, a decimal, and 2 digits after with a power of 10. So that's what scientific notation is, breaking it down till you have a power of 10. So we're going to say, let's say there is a decimal here, and I wanted to bring this down further. So if there was a decimal here, and I wanted to bring the decimal into this space here, what would I have to do? How much more would I have to multiply by? So it's 2 digits I'm looking at, right? So that means I'm going to write now 5.37 times 2 digits means 2 placeholders. So multiplied by 100, and I'm going to keep my multiplied by 1,000. Okay? So now when I do 100 times 1,000, what do I get? Multiplied by 2. I get multiplied by, sorry, did I miss a 0 there? No, I didn't. So multiplied by 100,000. So now you already know how to turn this into a power of 10. Okay? So in order to turn this into a power of 10, I count my zeros. 1, 2, 3, 4, 5. So this is going to be 5.37 multiplied by 10 to the power of 1, 2, 3, 4, 5. And now I've turned my number into a scientific notation. So we had this really big number, and we brought it down to a smaller number that is easier to understand. Okay, so that's what scientific notation is. So now I'm going to take this whole thing and I'm going to show it to you in a faster or easier method. So I'm just going to actually do it on, I was wondering if I could do it on the slide. So I'm going to see if I can go here and kind of work here, and hopefully you can still see on the screen. So if I have, so I'll do it in purple. If I have the 537,000. So in class, I've talked about how if we have a number in standard form, a whole number, there's an invisible decimal somewhere in this number. So somewhere in this number, there's an invisible decimal. And it exists. It exists at the very end of the number. So there is a decimal sitting right out here. So what you can do, an easier way to do, instead of going through this whole process to get to my scientific notation, I just say, okay, I know there's an invisible decimal at the very end of this number. It's right here. Now, how many spaces do I need to move in to turn it into a number that's a whole number with only 2 decimal spaces after? So I say, okay, what do I need to do? So I'm going to say, I'm going to take this decimal, I'm going to start moving it. 1, 2, 3, 4, 5. So I know I had to move 5 spaces. So the same concept, I have 5.37 multiplied by 10 to the power. How many spaces did I move in? I moved in 5 spaces. So that's scientific notation, taking a number and bringing it down to scientific notation. Okay, so I'm going to give you one to do yourself. So you can use either process. If you like this longer written out process, go for it. If you find this easier, go for it. Whatever you want to do, it's up to you. So let me give you another number that we can use. So the number I'm going to go with is, let's say I have 653. Okay, so if you take this number and put it into scientific notation, go ahead, pause the video, get it into scientific notation, and then come right back to me. Okay, so welcome back, and now I'm going to take you through this again. I'm going to go with the easier way because it's so much easier. And I know my zero is at the my decimal is at the very end of that 0, the last digit. And I'm moving in how many spaces? 1, 2, 3, 4, 5. And if I'm moving in 5 spaces, it's going to be 6.53 multiplied by 10 to the power of 5. And that is my scientific notation for that. And now I'm going to give you one more question that I'm going to kind of leave you with and see if you can figure it out on your own. So, if you've noticed with scientific notation, there's only 2 digits after the decimal, so you need to round your number. If it is a number that has more digits, you need to round it to the to the point where you only have 3 digits at the very beginning of your number. So, thinking of COVID cases again, in the world right now, so as of yesterday's data, in the world we have, sorry, I'm just trying to get the right number down. So we have that many COVID cases. Now that's a really big number. So how would you take this number and put it into scientific notation so that it's a little bit easier to understand? So I want you to try that. Again, remember that I want to only have these 3 digits showing. So you want to round your number so only these 3 digits are there. The rest of these become zeros, and then you move into scientific notation. So you're going to try that, and then you are going to come back and show me your working class.